Hello students, firstly I would like to welcome you all to Onboard Digital classes. As you can see today I am not in my studio. Therefore, there might be some problem regarding sounds. Alright. Yet I am making this video because some of my students had queries regarding this particular topic. And from the thumbnail I hope you must have guessed that today's topic. Today's topic is winds, right? When it comes to geography, normally what students does is they tend to study only those things which is easy for them to study. For instance, they study about the physical features of Bharat, which includes peaks, plateaus, and some of the students might even study about drainage system, right? And I've seen many students studying about the left tributaries of the major drainage system in Bharat and the right tributaries, right? And even if they study further, they study some minerals in news, okay? But they tend to neglect topics like this, which is very important if you are studying or if you are giving exams like UPSC or any state PCS. All right. So keeping that in mind, we shall discuss today's topic. And I would request all the students to kindly watch this video till the end. And if you like the video, please consider giving this video thumbs up and also comment your thoughts, how you thought about this class. All right. And also don't forget to share it among your friends and family. And if you have not subscribed to our YouTube channel, I would request all the students to kindly subscribe to our YouTube channel as well. All right. Having said that, let's begin today's class. So let's discuss today's class. As you all know, we'll be discussing about wind system. And there are different types of winds, as you can see here. Westerly, east, northeast trade winds. We'll be discussing about this one by one. First of all, let's understand what is a wind. Okay, before understanding this, we will draw some picture. What is this? This is a jar, for instance. Okay, this is an empty jar. Do you think that the air particles are present in this jar? Yes, these are air particles. These air particles are present in this jar, but these air particles which is present inside this jar, this is not a wind. Why it's not a wind? Because the wind, the air, in order to be a wind, it has to be in a movement. It has to be in a motion, right? As you can see here, the air in motion is called wind, right? This is a simple definition of a wind. If you are supposed to write about wind in, especially when you are doing GS paper and when you are writing about wind, just this much is sufficient. Okay, you should not complicate things because too much complications is not very good, especially if you are writing mains in that much pressure. Yes, the more simple that you make your question, the more simple that you make your answer, the better for you. All right. As you know, as we have discussed that the air which is in motion, this is called wind. Okay. Now, why does the air moves in a motion? Why? It is because of something called pressure, right? For instance, if you see that air always moves from high pressure to low pressure, always from high pressure to low pressure. This is also something that you must keep in mind. As you can see here, the wind blows from high pressure to low pressure. All right. Now let's understand the fundamental question. What is that question? Why is the air in motion? Why? It is because of something called pressure belts. As we all know that there are two type of pressure belts basically, right? One is the low pressure belt and the other one is the high pressure belt, right? And we know that wind blows from high pressure belt to low pressure belt. It is always from high pressure belts to low pressure belt, as you can see here, right? And point number 2 says the air is set in motion due to differences in atmospheric pressure, right? When we do atmospheric pressure, the chapter called atmospheric pressure, there we shall be discussing about various types of pressures, right? Just for today, remember one thing, that is there are two pressure zones. One is low pressure zone and another one is high pressure zone. Okay, and wind always blows from high pressure zone to low pressure zone. All right. And what is the instrument that is used to measure wind? It is called ammometer. Right. This is the image as you can see here in this slide. Moving ahead, there are various types of winds, which includes primary winds, Okay, secondary winds and tertiary winds. There are basically three type of winds, and primary winds are further classified into trade winds, westerlies, and easterlies. Similarly, secondary winds are also further classified into seasonal winds, or they are even called monsoon of Bharat. Right? Even monsoons of Bharat is what? They are secondary winds. They're not primary winds. Okay, we'll be knowing about the differences of primary winds, secondary winds, and tertiary winds as well as we move ahead in the slide. And ultimately, at last, what do we have? We have tertiary winds, that is also called local winds. Right? In Bharat, it is most popularly known as Lu, L-O-O, Lu. Right? Normally in our area, that is in Sikkim, Darjeeling, Siliguri, we don't really have this phenomenon of Lu. Okay. But you never know with the climate change and whatever is happening today, right? The effects of climate change in future, we might see Lu even in Siliguri, you know. So we need to be mindful of that. Anyway, let's discuss about primary winds one by one. Primary winds, as you can see here, it is also called what? It is also called planetary winds. Okay. And what's the nature of this wind? It is permanent. It is always permanent. Okay. It blows continuously in one direction. Okay. It does not change the direction. There are three types of primary winds. Even primary winds are classified into three different categories. What are those? One is trade winds. Second one is westerlies. And the third one is easterlies. All right. Let's study about trade winds now. Now, why are trade winds called trade winds? Because trade winds facilitated trade, especially in the Atlantic Ocean. As you can see, this is an Atlantic Ocean, right? And during old times, it used to facilitate the trade. That is the reason why it is called the trade winds. All right, so simple. And the second point says direction change due to Coriolis force. Okay, okay, let's change the color because you might not be able to see with this. We will be taking blue. All right, let's take blue. You see, these trade winds are supposed to be in this direction, right? These trade winds are supposed to move like this, and these trade winds are supposed to move in this straight line, right? But as you can see here in the northern hemisphere, what happens in the northern hemisphere? Suppose this is an equator, right? This is an equator, 0 degree equator. Now this part is called northern hemisphere and this part is called southern hemisphere. And in northern hemisphere, what happens is that warm air which changes the direction, okay, and this air which was supposed to move straight, it just changes the direction. And why does this air change the direction? It is due to something called Coriolis force. Now, why does this Coriolis force occur? It is because due to the rotation of the earth. All right, it is due to rotation of the earth. The Coriolis force occurs, right? Anyway, we'll be discussing about Coriolis force in the further slides as well. Okay, both warm air does not collide but converge, and near equator makes moisture rise. This is up. Okay, this the spelling is not very good. UP up, and pin is also not working, so for some reason. Okay, up and cause heavy rains. As you can see here, this zone is called ITCZ. ITCZ. What this means is intertropical convergent zone. Basically, what happens in this area is that there's so many warm air which is rising, right? Warm air which is rising, but then this warm air does not collide with each other. Instead, it converges, right? It converges, and there are so many moisture in this area. All right, so many moistures are in this area. Now, when there is a moisture, what happens? There is a heavy rainfall. All right, rainfall is very much heavy, and as you can see in this image, right? This is what? ITCZ, this zone. Okay, and you can see Amazon rainforest is also in this zone. Congo river basin, Congo rainforest is also in this zone, and Indonesia rainforest is also in this zone. Why? Because there are so many moisture, and with moisture what happens? There is many rainfall, right? There is much rainfall. Now if there is rainfall, then obviously there will be tropical rainforest, and most tropical rainforest falls within ITCZ. Okay. Next is, we have also discussed about Coriolis force, right? What is Coriolis force? We'll discuss this in detail. It is nothing but it is a force which is caused due to Earth's rotation. Earth is rotating, right? Earth is rotating in its axis. This is a tilted axis. Okay. Earth moves in this direction, right? This is tilted, Earth is tilted. All right. So in tilted axis, it rotates. Now, what happens? Why this Coriolis force is occurring? It is due to, because the distance in the equator is much more larger than the distance in the poles, right? The distance in the pole is much more smaller than the distance in the equator. That is the reason why Coriolis force occurs in the equator. Okay, let's discuss about this. Coriolis force is an apparent force caused by Earth's rotation. All right, the Coriolis force is responsible for deflating winds towards the right in the northern hemisphere and towards the left in the southern hemisphere. Okay, what this means is, let's move back to this trade winds. What it says is that because of this Coriolis force, the winds that were supposed to come directly, right, like this, due to this Coriolis force, what happens in the northern hemisphere? It moves towards right direction, in the right direction. All right, in the southern hemisphere, it moves towards left direction. All right, so that is the basic meaning of that sentence. Okay, it is why is that happening? It is because of Coriolis force. All right, because rotation speed of at an equator is more as compared to the poles in 24 hours. You see the rotation speed in the, this is the equator, the rotation speed in the equator is much more than what is in the poles. All right, and therefore it has to complete the distance, as we have already discussed, right? The distance is much more bigger as compared to poles, right? It had to complete the distance faster than the poles. That is the reason why the variation in the speed. All right, moving ahead to the next slide. Next, what we have is westerlies. This is another type of primary winds, right? Westerlies in name itself suggests that it starts from the west. As you can see here, these are westerlies. Okay, these are westerlies. Now, one thing you must remember about westerlies is that in the southern hemisphere, as you can see here, in the southern hemisphere, westerlies are much more fierce. The reason is because there is very less land masses. Okay, you see in the northern hemisphere there is much more land mass, right? You see these are all the land mass in the northern hemisphere, but then in the southern hemisphere, when it where there westerlies exist, there is a very less land mass. All right, so that is the reason why it's much more fierce in the southern hemisphere. All right, so let's move ahead to post polar easterlies. All right, as you know that polar easterlies, like westerlies, it starts, westerlies started in which direction? In the west direction, right? Similarly, polar easterlies starts in the east direction. All right, starts from east. Okay, and what happens is, okay, which area is polar easterlies? This 60° north, as you can see here, 60° north and 60° south. All right, 60° north and 60° south, this region is called the polar easterlies. Now what happens in this is, basically there are subpolar fronts which gets created. Okay, that is the reason why there are so many cyclones and hurricanes in this area. All right, recently even America faced a very tragic hurricane. Right, what was the name of that hurricane? If you are following the current affairs, please comment down on the comment box. All right, moving ahead, what are the factors that governs the pattern of planetary winds? Let's discuss about this. First, it is the latitudinal variation of the atmospheric heating. Yeah, we have already discussed about this. There are various latitudes. For instance, if you go up the atmosphere, the latitude heat also varies, isn't it? We will be discussing about that when we discuss heat. Okay, but today we are discussing about winds, right? We will be discussing about latent heat also. All right. Anyway, moving ahead to emergence of pressure belts. We already discussed about pressure belts also, right? Low pressure belt and high pressure belts. The migration of belts following apparent path of the sun. Yes, because these belts also, what does it do? It migrates. That is that it moves from one place to another. It is not necessary that if this particular area is low pressure zone, tomorrow this pressure area might be a high pressure zone. It is not hard and fast rule that once an area is a low pressure zone, it will remain in low pressure zone throughout its lifetime. No, it does not happen like that. All right. Next is the distribution of continents and ocean. Even we discussed when we were discussing about westerlies, right? When there is the westerlies is much more fierce in which hemisphere? It is much more fierce in the southern hemisphere, right? And also the rotation of the earth. Because of the rotation of the earth, what happens? Coriolis force. All right. Now we move to second type of winds, and that is seasonal winds. Okay. Seasonal winds are also known as periodic winds or variable winds. For instance, monsoon. Why monsoon is a periodic wind? Because in Bharat, monsoon comes in which month? Basically, monsoon comes in the month of June and July, right? So it is like that is fixed, isn't it? It does not come in August or September, right? It is fixed, June and July. That is the reason why it's called periodic, all right? Periodic winds are these winds that flow periodically. For instance, land bridge and sea bridge. Periodically means what? Land bridge and sea bridge. We had studied about land bridge and sea bridge when we were studying in class 8, right? But still we will be studying about land bridge and sea bridge in this class as well. Okay, let's move ahead. As you can see here in the month of June, right? The monsoon is entering from the sea to land, right? From sea to land. And in the winter section, and in winter, that is in January, from land to sea. So that is the movement of monsoons in India. Okay. Monsoons wind are seasonal winds characterized by complete reversal in the direction from one season to another, mainly due to shift of ITCZ. ITCZ we had already discussed, right? If this is a Earth, this is an equator, and here I had said that there lies an ITCZ, but ITCZ does not remain always in equator. Sometimes it shifts to the northern hemisphere, sometimes it shifts to southern hemisphere. All right, that's the reason why monsoon winds are also determined by the shift of ITCZ. All right, so it was traditionally explained as land bridge and sea bridge. Traditionally means what? That means previously monsoon used to be expressed in land as not in as land bridge and sea bridge, right? They blow from the sea to the land in summer and from land to sea in winter. That is the reason why traditionally it was explained as land bridge and sea bridge, as we have discussed here, right? For instance, if you see in the summer, what happens? It blows from the sea to the land, and in the winter, it blows from land to the sea. Okay. Now, next, what we have is land bridge and sea bridge. As you can see, this is a land bridge and this is a sea bridge. Now, during a day, what happens is that specific heat of water is high. Now, what specific heat means is, for instance, during daytime, the sea does not get heated up faster, whereas land heated up much more faster than as compared to sea, right? Now, what happens then? The warm air rises, right? For instance, let me change the color of the pen because it is not much visible, right? For instance, the warm air rises up and there is a vacant area, and this creates what? Low pressure here, low pressure. Now the cool air from the sea occupies the space and the low pressure is created here. All right. Now at night what happens is that reverse. For instance, at night land gets cooler much more faster. All right. And sea is still warmer, isn't it? And at night what happens? The warm air from sea rises, okay, and the cool air from the land occupies this space. So that is what land bridge and sea bridge is. At during the day there is a low pressure zone created at land, and during night low pressure zone is created at sea. Okay, so that is what land bridge and sea bridge is all about. The pressure gradient is from sea to land, that is called sea bridge, right? The pressure gradient is from sea to land. The cold winds from the sea to land, that is called what? Sea breeze. And at night, the pressure gradient is from land to sea, and that is called land bridge. Simple, isn't it? Now next what we have is local winds. Local winds. In Bharat, as we have already discussed, local winds is also called tertiary winds, right? These blow only during a particular period in a very, very local area, right? Even in Bharat, we don't find Lu everywhere across Bharat, right? This is a specific zone, as you can see, this is the shaded region. Here we can find Lu, or even this place. This is called mango shower also, right? Okay, let's discuss some example. Mistral, that is called the local air in Europe, that is called Mistral and Bora. Okay, these are some names that you must remember. For instance, there are warm winds, there are local winds and cold local winds. For instance, Pampora. How question is framed from this? Normally, the examiner keeps options like this: Pampera, Regal, Bora, and Zonda. Which among the following is warm winds? So if you know Zonda is a warm wind, you'll be able to answer the question. So this is something that you must keep in mind. All right. Next, what we have is jet streams. Okay. Last topic is jet streams. Upper air current. Now, jet stream is nothing but it's an upper air current in upper atmosphere. Okay, jet stream is always in the upper atmosphere. This is something that you must keep in mind. Okay, are rivers of air. It is nothing but it is called rivers of air. Okay, narrow bands of strong and fast flowing meandering winds. Strong. These jet streams are very much strong and they are very narrow. Okay, they are not like, they do not occur in a very large area. They do not occur in a very large area. They're very narrow and they're very fast. Okay, and they're called meandering also. What is the meaning of the word meandering? If you see the flow of rivers, no, rivers flow like this, right? Like this, like this, like this. So this is called the meandering. Even jet stream also flows meanderingly, right? So due to very, very less friction. And why? Because the friction is very much less, because there is very less presence of atmosphere. Next, what we have is geostrophic winds. It blows parallel to isobars. The concept of isobars and isotherms is something that we'll be discussing in the next chapter. All right. And another is there is westerly winds. It blows from west to east. It's quite simple. All right. Next is the formation. How is jet stream formed? When warm air masses meet cold air masses in the atmosphere. Okay, there is a warm air of mass and cold air of mass when it meets in the atmosphere, and that's happening where? In the top atmosphere. All right. Next, what we have is jet streams are formed in both the hemisphere. That means jet streams are not only formed in the northern hemisphere, but it is also formed in the southern hemisphere. Okay, northern hemisphere and also the southern hemisphere. And in both hemisphere, two jet streams are formed. As you can see here, this is in the northern hemisphere one jet stream, and this is polar jet stream, and this is subtropical jet stream in the northern hemisphere. In the southern hemisphere also, two jet streams are formed. All right. And what are the factors for jet streams? What are the factors that is essential, that is a requirement for the formation of jet streams? First is differential heating, pressure gradient. That means there has to be a cold air masses and a hot air masses. Only in that condition jet streams are formed. Okay. And also factors affecting jet streams are Coriolis force. So Coriolis force is very, very important. All right. So with this we come to end, and thank you very, very much if you have watched this video, and please do like, share and subscribe the channel also. Right. And there's a special announcement to those aspirants who are preparing for SPSC and WBCS. If you are looking for a paid badge, online paid badge, Onboard Digital class is coming up with a very affordable class starting from 26th of January 2025. All right. It is the course that is for 6 months, and for 6 months you'll have to pay only 9,999 rupees. Okay. And if you are interested, you can join the class. With this, I would like to end today's video.